Dear students, following question is a good 2-mark question from topic of flow through pipes plus laminar flow. So here some conditions are given that water flows at steady rate of 1 meter per second through a 50 diameter pipe that is sloping upwards at 45° to horizontal, and I have drawn a rough sketch of the same. And it is given that at some section distance downstream of the inlet. Now please don't confuse that if this is inlet, downstream will be lying here. No, downstream always lies in the direction of flow. So let us say there is some point 1 that is lying at some distance at downstream of the flow where pressure is 700 kPa. For your information, those who have confusion between these things, 1 kPa is equal to 1 kilonewton per meter square. That means 700 kPa is 700 kilonewton per meter square. And at a section 30 meter further along the pipe, as I have shown, 30 meter further along the pipe, the pressure is given as 460 kPa, that is 460 kilonewton per meter square. Now, if this is 30, this inclined length is 30, for this angle to be 45°, the Z, if we pass a datum through line through point 1, Z comes out as 30 by root 2 meter. Now if we apply the Bernoulli's theorem between point 1 and point 2, we can write P1 upon gamma plus Z plus V1 square by 2G should be equal to V2 square by 2G, because cross sectional area of pipe is not changing and we assume that velocity more or less remains constant along the flow. So P1 by gamma plus Z1 is equal to P2 by gamma plus Z2 plus delta H, where this is point 2 under consideration. So Z2 is 30 by root 2 meter and Z1 is 0 because it is lying on the datum that we have selected. So just putting all the things in Newton per meter square, we end up with delta H as 3.25 meter. I have written it as 10 to the power 3 just to convert kilonewton to Newton, and 9810, if I write value of gamma as 9.81 kilonewton per meter cube in Newton per meter cube, it will be written as 9810. So delta H comes out as 3.25 meter. Now from knowledge of laminar flow through pipes, we know that tau, that is average shear stress for flow along pipe that is inclined to the horizontal, is given by gamma into del H upon del X into R by 2. Now this is the one formula that students are expected to remember, because everything can't be perfectly logical in the questions in GATE. Something or some formulae you must be learning. So students are advised to learn the formulae that are given in chapter of laminar flow and boundary layer theory of fluid mechanics. That may help. So just substituting the value of gamma as 9810 Newton per meter cube del H upon del X. Now 3.25 meter is taking loss in 30 meter and I have taken a reference direction. This is X, this is Y. Now please note that while applying this del H upon del X, don't do the mistake of taking del X along cos component. No, because this head loss is taking place when fluid is traveling the actual length of 30 meter. That's why it has to be 30 meter into R by 2. Now diameter is given as 50 which is 50 into 10 to the power minus 3 meter. So R by 2 will be, R will be D by 2, and one more 2 from this equation is coming. So tau is coming out as 13.284 Newton per meter square, making A as the correct and closest choice. Thank you.